Welcome to our Network, Cabling, and Topology module. There are two types of network media, bounded and unbounded. Bounded involves some type of cabling, and unbounded involves wireless technologies. There are several different data link layer technologies that can be used to transmit data. These provide different functionalities and speeds and different levels of security and protection. The most commonly used type of cabling involves copper, which is used to carry electrical signals. Fiber optic cabling is also used, and those cables transmit pulses of light. Either binary or analog data can be transmitted over most types of cable. And the most common type of network disruption involves cabling problems at the physical layer or layer 1 of the OSI model. Coax cabling uses analog signals which can be amplified. Coax generally provides higher performance than twisted pair and is commonly used in radio frequency analog communications. This cable is shielded and is commonly used for cable television and satellite transmissions. Probably one of the most common types of cabling is twisted pair cabling, which generally uses the Ethernet protocol, and these cables have categories such as Cat5e, which tell you the specifications that the cable will operate at. These are very inexpensive and easy to work with, and they repeat binary signals. Twisted pair cabling is also used for telephone systems. You usually have a wiring closet in your facility where all of your cables gather from the entire building and they terminate into a punch-down panel. Patch panels provide a physical layer endpoint for all of the cables coming from the wall jacks in your facility. Coaxial cable, also known as coax cable, is very resistant to electromagnetic interference and radio frequency interference than twisted pair. It is more expensive than twisted pair, but can be used for longer Ethernet segments. There's a copper core in the middle of the coax cable that carries multiple analog signals to provide broadband transmission. It can generally transmit a greater bandwidth and greater distance than twisted pair. Typically, coax is only used for broadband communications, and there are three different types. Thin-net Ethernet, also known as 10-base-2 or RG58, had a limitation of 185 meters per run. Thick-net Ethernet segments were limited to 500 meters, and these were known as 10-base-5, RG8, or RG11. And broadband coax is used generally by cable TV systems and uses a twist-on F fitting. RG6 is used exclusively for satellite hookups and cable TV. You can use RG59 for analog cable TV signals, but that will not support the higher bandwidth used for satellite signals and should not be used for satellite connections. Coax is not being used as frequently today, but is still used in high noise areas such as elevator shafts and in areas where there are large machinery that could interfere with twisted pair signals. Twisted pair cabling provides a lower cost and lower speed transmission medium using twisted copper wires. Unshielded twisted pair and shielded twisted pair both use 4 pairs of colored wires that are twisted together in groups of 2, and this is why they are known as twisted pair cabling. It works well and costs less than other network media. However, unshielded twisted pair is very vulnerable to interference, eavesdropping, and crosstalk, and is considered less secure than shielded twisted pair and fiber cabling. Shielded twisted pair provides an extra outer foil shielding, which allows it to resist electromagnetic interference and radio frequency interference. Category ratings have been established to differentiate between different types of cable. Category 1 is voice-grade telephone cable and is not recommended for use in computer networks. Category 3 provided 10 megabits per second Ethernet installations. Category 4 raised the speed to 16 megabits per second. The most popular installation for the last several years has been either Category 5 or Category 5e. Cat5 supported 100 megabits per second, and Cat5e supported gigabit Ethernet. Cat5e used heavier conductors with more twists than the original Cat5 in order to increase the bandwidth. An upgrade to Cat5 is Cat6 and Cat6a. This is the standard for gigabit Ethernet speeds and is also backwards compatible with Cat5 and Cat5e. This is generally the minimum grade of cabling being installed today. Category 6 can be run up to 60 meters, but Category 6A now supports segments up to 100 meters in length. Category 7 is the new standard for 10 gigabit Ethernet, and this will be used for backbones or networks requiring the highest speed possible. For the CISSP examination, you should remember that generally Ethernet cables can never be run more than 100 meters. When we're dealing with copper media, we do have some issues that we need to be concerned with. Noise, such as electromagnetic interference and radio frequency interference, can corrupt binary signals and cause problems in our network. Attenuation causes us to lose signal strength as we move over significant distances, and this is why we do not use twisted pair cabling in lengths longer than 100 meters. We also have to worry about crosstalk, where one signal is spilling over into a neighboring wire. The most susceptible cabling for this problem is unshielded twisted pair, and with shielded twisted pair you have much less chance of crosstalk occurring. Fiber optic cable is a significant improvement over both twisted pair and coax cabling. Fiber optic cable can be either single mode or multi-mode. Fiber optic cables transmit light over glass or plastic rather than using copper wires. This is the most expensive solution, but is also considered the most secure, and it should be considered the best solution because it provides higher speeds and less attenuation. If you see a question on the CISSP examination regarding the best type of cabling, fiber optic would most likely be the answer, because when they are looking for the best solution, money does not matter. Fiber optic cable is very resistant to eavesdropping and outside interference. However, it's very expensive because it's hard to work with. It is very easy to break the glass or plastic inside fiber optic cabling, and therefore you need individuals who are specially trained in working with fiber optic cable. With fiber optic cable, you will commonly use a snap-in connector or SC, or a lucent connector or LC, to a network interface card or a wall jack. Multi-mode fiber optic cable uses LED signals and is generally used in buildings, and single-mode fiber uses laser light and can run many kilometers. For the CISSP examination, you should remember that single-mode fiber can be used to run cable over very long distances, and multi-mode fiber is used for shorter runs and is generally used in buildings. Fiber optic cables are typically run as duplex pairs, and one of the wires is used to send data and the other is used to receive data. There are several different types of LAN topologies. The bus topology uses a single cable for all of the computers attached, and all of the traffic on the cable is received on all computer systems. The problem with bus computer networks is that if one station has a problem, all of the other computers could be affected. With a ring communication, it is very similar to a bus connection in that it uses cabling in a closed loop among all of the stations, and it has the same problem as the bus. If one computer goes offline, all of the computers on the ring can be affected. We typically do not see bus or ring topologies being used in modern networks. The star topology is the most common type of networking topology, and here all computers are connected to a central networking device, usually a switch. With this type of network, you do have a single point of failure in the switch, so if the switch goes offline, all of your computers will lose their connectivity to the network. However, if a single computer or group of computers go offline, it will not affect the rest of the network. With a tree topology, it is a bus topology that rather than using a linear cable, uses branches of cables, and like the bus and the ring topology, we really don't see this being used very often. With a mesh topology, servers are interconnected to each other, providing redundancy and high availability. Mesh networks are more expensive because they require additional network interface cards for your devices and additional cabling, but these are typically used in clusters of servers for server farms or data centers. For the CISSP examination, you should remember that the mesh network provides you with the highest amount of redundancy and reliability, however, it is also the most expensive. This concludes our network cabling and topology module. Thank you for watching.